Hello there, my name is Ajiboye Isaac, and today we want to look at application of ratio, proportion, and percentages. Application of ratio, proportion, and percentages. Our learning objectives. At the end of the lesson, learners should be able to express the percentage of a quantity, increase a quantity by a given percentage, solve problems of percentages. Okay. And we have an example of the questions that make application of percentages. Example, the size of a quantity first doubles and then increases by 16%. After a short time, the size decreases again by 16%. What is the net increase in size of the quantity? So we say, let the quantity be x. And so if the quantity is x, the x in itself is 100%. So x is equal to 100% of x. So the quantity is doubled, means you multiply it by 2 or times 2. So 2x is what we get. And 2x in terms of percentage is 200%. So we're told that there's an increase in x, and that increase is 16% increase. So 16% of x, all right, will be added to the already increase that we have earlier. So that means 16% of x plus 200% of x. And that again will give us 216% of x. Now, there is also a decrease by 16%. So that means the decrease, we'll find the 16% of x and subtract it from the overall increase so far. So 16% decrease of x simply equals to 216% of x minus 16% of x. And that again will give us 200%. Net increase, therefore, will be 200% minus the original percentage that we have. So 200% minus 100%. That is equal to 100%. Example 2. Factory P produces 20,000 bags of cement per day, while Factory Q produces 15,000 bags per day. If P produces production of 5% and Q increases its production by 5%, determine the loss in the number of bags per day produced by the two factories. So we're told that two firms or two factories are producing bags of cement. One produces 20,000 per day, the other 15,000 per day. So the total number of bags produced per day by these two factories will therefore be 20,000 plus 15,000, which will therefore be equals to 35,000. Now, 5% of the production of P will be 5 over 100 times 20,000. That will give us 1,000 bags. Now, when there is a reduction of 5%, it simply means that we'll remove the 1,000 bags from the usual 20,000 bags per day. So doing that, we have 19,000 left. That is 20,000 minus 1,000 reduction is equal to 19,000 bags. So 5% of Q is 5 over 100 times 15,000, and that will give us 750 bags. That 750 bags is the increase in production by Factory Q. So that suggests the new production per day would therefore be 15,000 plus the increase 750, which is equal to 15,750 bags per day. Now, the total new production by the two factories would therefore be equals to the 19,000, that is the reduction from 20,000 to 19,000, plus 15,750, which is the increase of Q per day. So when we add the two together, we have 34,750. If we therefore want to find the loss, we therefore subtract the new production per day from the old production per day. So that will therefore be equals to 35,000 minus 34,750, which will give us 250 bags. Example 3. If the length of a square is increased by 20%, while its breadth is decreased by 20% to form a rectangle, what is the ratio of the area of the rectangle formed to the area of the square? So already let us call the sides of the square length and breadth. And we know that the length and breadth will be equal in terms of the square. So area of the square will therefore be length times breadth, right? You know, if it is a square, the length will be equal to the breadth. Okay, and now the length of the rectangle that is formed by the reduction of 20% or by the increase of 20% would therefore be 20% of L plus L. That's increase. That's how to do increase in percentage. So 20% of L is 0.2 L, and plus L, that will give us 1.2 L, which means I have converted the 20% to decimal. 20% is 0.2. So plus 1 L will give us 1.2 L. Now the breadth of the rectangle form is a reduction of 20% from the original breadth of the square. So the breadth of the rectangle will now be B minus 20% of the breadth of the square. Okay, so that will give us B minus 0.2B, and that will be equals to 0.8B. Now the area of the rectangle will now be equals to 1.2 length times 0.8 breadth. 1.2 length times 0.8 breadth. Okay, now the ratio of the area of the rectangle to that of the area of the square will therefore be equals to 1.2 length times 0.8 breadth, which is the area of the rectangle, to the length times breadth of the square. And we had already discussed in that note that ratio can also be interpreted as division. So I am saying 1.2 L times 0.8 breadth is equal over length times breadth. And then when we do that simplification, what we will get will be 96 over 100. In simplifying, the equivalent fraction will be 24 over 25. And that 24 over 25 can be expressed in ratio. And that will give us 24 ratio 25. So please attend this classwork and forward your attempts to my WhatsApp number. Please attend the assignment right away. Attend the assignment and also forward it to my WhatsApp number. I want to commend the effort of those of you that are attempting the classwork. You're doing very well. Keep it up. And let me also tell you that you can go to my YouTube channel, Mathzik at YouTube channel. That is MATHZIK at YouTube channel for more videos and more examples on ratio, proportion, and percentages. Thank you for listening.